from one place to another place. Here matter will not transfer from one place to another place. Only energy will transfer from one place to another place. The previous class I gave one example. Let us consider a spoon. So let us on our stove, gas stove. Keep one end of the spoon into your hand and other end in the flame. After, are you able to hold that spoon long time? Anyone please respond?
No, sir.
No, why? What is the
It
reason?
will become hot.
It's
The spoon
heated
will
up,
become.
sir, so we can't touch it.
The temperature of the spoon gradually goes on increases. Am I correct?
Yes, sir.
Yes, sir.
Why temperature of the spoon increases gradually at your fingers?
Heat transfer occurs.
It is transferred through the spoon from the flame. Am I correct or not?
Yes, sir.
So while heat is transferred from one end of the spoon to the other end of the spoon molecules will moving or just they are retaining in their own places. Tell me.
Sir, they're vibrating.
The spoon, those vibrations also not visible to us. The spoon molecules won't move from one place to another place. Am I correct? But transfer heat energy from one part of the particle to another part of the one part of the rod to the another part of the rod. Yesterday I gave one example. This is the rod. What happened? It is one end of the rod is kept in hot bath. Another end of the rod is kept in ice bath. What is the meaning of water bath and ice bath? One end is kept in ice vessel, other end is kept in water vessel, which is slowly heating by using some arrangements, either stove or gas stove, so or Bunsen burner. So we are increasing the temperature of this water gradually. As a result, what happened? Heat will transfer. While heat is transferring from one part of the body to, this is cross-sectional 1 of the rod, this is cross-sectional 2 of the rod, this is cross-sectional 3, cross-sectional 4, cross-sectional 5, like that. So heat is transferred from hot region to cold region. Am I correct? While heat is transferring from hot region to cold region, let us suppose that 100 calories of heat energy is coming at one particular moment to the first cross section. So will 100 calories of heat energy will transfer to the next cross section in initial state?
No, sir.
Some part of heat energy will be transferred by this cross section. So remaining will be transferred to the, as a result, this cross section temperature slowly increases. Is it clear? Again, this next cross section absorbs the heat energy sent from the cross section A, and some amount of heat energy is absorbed by this cross section, and remaining will transfer to the next cross section of the rod. As a result, each cross section of the rod temperature changes, increases slightly. After reaching certain state, the state where the temperature of the each cross section increases continuously, that state we are going to call it as variable state. After certain time, the temperature of the each cross section becomes constant. Let this is some 90 degrees Celsius. The cross section very close to the hot region, maybe 80. The cross section, next cross section some 75, 70. Like that, the temperature of the different cross sections of the rod may be different, but each cross section temperature remains constant. Is it clear? That state we are going to call it as steady state. Once its steady state is reaching, once the each cross section reaches to its steady state, it does not absorb the heat energy, the which is coming from the hotter region, as the entire amount of the heat energy will transfer to the next cross section without absorbing. That state we are going to call it as steady state. Let us suppose that this is the gardening pipe. The one end of the gardening pipe is connected to the motor. Other end of the gardening pipe is, let us suppose that it is in your hand. So whenever it is new and whenever it is used first time, is there any water in the beginning? Tell me, in the water, in the pipe?
No, sir.
No. Let us suppose that you switch on the motor, electric motor. What happened? The water fills in this tube, and then it comes out from the, after filling the water completely throughout the volume of the tube, then only water will come out. Am I correct or not?
Yes, sir.
Each cross section will absorb, first each cross section will absorb some amount of water, and then after it is filling completely, then only it will transfer. Like that here also every cross section first increases, first absorbs some fraction of heat energy coming from the hotter region, and then increases its temperature. After its temperature becomes constant, how much amount of heat energy coming from the hotter end, that much amount of the heat energy will reach us to the cold end. That state we are going to call it as initial state. Is what? Variable state. In the variable state, only fraction of heat energy reached to the cross section will be transferred to the next cross sectional area. Is it clear? So once its temperature becomes constant, some amount of heat energy will be absorbed by this cross section, and remaining amount of heat energy will be transferred to the next cross section. Because of the absorbing heat energy, its temperature increases. So its temperature does not increases continuously. It will reaches to certain state, certain value. Once after reaching certain value, its temperature does not increases further. That state we are going to call it as steady state. Is it clear? The temperature of the two different cross sections of the rod. This is one cross section. This is another cross section. May be different. This may be 70. This may be 60. But temperature of each cross section remains constant in steady state. Is it clear? Temperature decreases when we move from hot end to the cold end. So what is Q by T? How I define Q by T? Tell me. The amount of heat energy transferred from the each cross-sectional area of the rod in unit time is defined as heat current or rate of flow of heat energy. Is it clear? In steady state, heat current through the each cross-section is same. Once its temperature of the individual cross-sections becomes constant, how much amount of heat energy coming from the hot end, that much amount of the heat energy will transfer to the cold end. Is it clear? Students, are you able to understanding what I am explaining?
Yes,
Yes,
sir.
Yes,
Heat energy is constant in steady state. So later I define temperature gradient. How I define temperature gradient? So during the heat transfer through the rod, the temperature difference between two cross sections and the ratio of temperature difference between the two cross sections and distance between the two cross sections, we are going to define it as temperature gradient. Clear? What is temperature gradient? Temperature gradient is nothing but dt by dx. As you move from cold end to hot end, temperature gradient becomes positive. Hot end to cold end, if you move, temperature gradient becomes positive. If you move from if you move from if you move from cold end to hot end, what happened? Temperature gradient is constant. If you move from hot end to cold end, what happened? So this is hot end. Here temperature may be 40. This is the cold end. Here temperature may be 25. The difference, length difference between two cross sections. Distance between the two cross sections here, let it be some 1 meter or 2 meters like that. What is the temperature gradient here? Here we are moving from hot end to cold end. This is first temperature, this is second temperature. First we are crossing this cross section. Finally we are crossing. So temperature difference means final temperature minus initial temperature. Here final temperature is 25, initial temperature is 40. As you move from hot end to cold end. In such a situation, final temperature minus initial temperature becomes how much? Negative.
Yes, sir.
Negative by 2. This is 15 by 2. This is the temperature gradient. While you are moving from hot end to cold end, temperature gradient becomes negative. While you are moving from cold end to hot end, temperature difference becomes, temperature gradient becomes positive. What is the unit of temperature gradient? Kelvin per meter or
Kelvin per meter.
degree Celsius per meter.
Yes,
Conversion
sir.
factor 1 Kelvin per meter equals to how many degrees per
1 degree.
100,
1 degree.
100 degrees Celsius.
1 Kelvin per
1 degree.
meter is
Sir,
equals
1
to 1
degree.
degree per
1
meter
degree per
only.
meter.
Is it clear? 1 degree Celsius change in temperature equals to 1 degree Celsius, 1 Kelvin change in temperature. Clear? So I think in our previous classes you may learn about thermometry, 5 scales of temperatures: Celsius scale, Kelvin scale, Fahrenheit scale, Reamer scale, Rankine scale, like that. Am I correct? Are you learned or not?
No, sir.
Different scale. Temperature can be measured in either in Fahrenheit. So, for example, if you went to any dispensary, so what happened? They will check your body temperature by using thermometer. Am I correct or not? How
Yes,
thermometer
sir.
work? How thermometer works? Tell me.
Sir, because of the mercury in the
Thermometer works on the principle of
Expansion of
expansions of
liquids and
solids
gases
or
on
expansions
heating.
of most of the substance expands on heating, contrasts on cooling. Am I correct? Most of the substances expands on cooling, expands on heating, contrasts on cooling. Is it clear? So
Yes, sir.
the liquid, the mercury also expands uniformly as it receives the heat energy. Is it clear? So different scales of temperatures. Your body temperature will measure in Fahrenheit when you go to the dispensary. Are you understanding what I am saying? So sometimes they are going to say that your body temperature is 101 degrees. Here, in which degrees they are explaining? Tell me. Degrees Fahrenheit. Am I correct? What is the conversion factor between degrees Fahrenheit and Kelvin scale? Here, in order to estimate the temperature of one particular body, we need to know two standard temperatures. Melting of ice, the temperature at which ice melts is considered as lower fixed temperature, lower fixed point. In Celsius scale, lower fixed point is considered as 0. In Kelvin scale, it is 273. In Fahrenheit scale, it is 32 degrees. So another fixed temperature is the temperature at which water boils. Boiling point of water in Celsius scale is 100
100
degrees.
degrees Celsius.
In Kelvin scale,
373 degrees
in
Celsius.
Fahrenheit scale,
212 degrees foreign.
Fahrenheit. Here, the gap between upper fixed temperature and lower fixed temperature is divided into 100 equal parts. Here also, in Kelvin scale also, they are divided into 100 equal parts. This is 100 equal parts. Clear? Here also 100 equal parts, but here 180 equal parts. Let us suppose that if your body temperature is this thermometer is kept in contact with your body. Let us suppose that length of the mercury column raised is up to here, up to here. Then how will you measure? Tell me, your body temperature. Let us suppose that this length is some lower fixed L1. This length is L2, upper fixed length. Clear? So when the temperature of the body is 0 degrees Celsius, then mercury in the thermometer will rise up to here only. If the temperature of the body is 100 degrees, mercury in the thermometer will rise up to here. This is L1, length of the mercury when the temperature of the body is 0 degrees Celsius. This is L2 when the temperature of the body is 100 degrees Celsius. So when the temperature of the body is some T or some C, let length of the mercury column is L. Here the mercury expand uniformly. The change in temperature for 100 degrees Celsius is how much? L2 minus L1. Am I correct? Change in length. For change in temperature of the body from 0 to 100 degrees Celsius, change in length in the mercury level is L2 minus L1. Am I correct? If the body temperature changes from 0 to C degrees Celsius, length value is changes from L to L1 to L. Am I correct?
Yes, sir.
This expands uniformly. That is why C minus 0 by 100 minus 0 is equals to L minus L1 divided by L2 minus L1. Like that, F minus 32 in Fahrenheit divided by 212 minus 32. C minus 273 divided by not C, K minus 273 minus 373 minus 273. This is the conversion factor. Temperature in any scale minus lower fixed temperature, lower fixed point by upper fixed point minus lower fixed point is equals to constant. That constant is this much. Why? Because the expansion is uniform. As the temperature increases, expansion of the mercury is uniform. That is why we consider they are directly proportional to each other. Change in temperature and change in length of the mercury is directly proportional to each other. So we developed like this. This is C by 100 is equals to F minus 32 by 180 and K minus 273 by 100. This is the conversion factors. Is it clear? Here 100 degrees Celsius change in temperature is equals to 100 Kelvin change in temperature, which is equals to 180 degrees Fahrenheit change in temperature. That is why 1 degree Celsius change in temperature is equals to 1 Kelvin change in temperature. So we have another branch of heat, that is calorimetry. Thermometry is a branch of physics which deals with study of measurement of temperature, whereas calorimetry is a branch of physics which deals with study of measurement of heat energy. The device which is used to measure the temperature is thermometer. Thermometer works on the principle of expansion of the liquids. As if you supply heat energy to the liquid, expansions of the substance by supplying heat energy is the working principle. In thermometer, we are going to use mercury instead of water. Why we are going to use mercury? Why we are not going to use water? Tell me. The
Mercury
expansion of the water is non-uniform, whereas expansion of the mercury is uniform to the temperature. Is it clear? So, for example, if you increase the temperature of the water and mercury, water temperature increases from 0 to 4. Water does not expand. Instead of expansion, it contrasts. Similarly, if you increase the temperature of the water from 4 to 100 degrees Celsius, it expands like all other substances. This is called anomalous expansion of the water. Whereas the mercury expansion is uniform, 0 to 100, 0 to whatever required temperature. Is it clear? Expansion of the water is non-uniform, whereas expansion of the thermal expansion of the mercury is uniform, whereas water sticks to the walls of the mercury bore. The mercury capillary tube untadi kada. If I used water, the water molecule will stick to the walls of the capillary tube in the thermometer, whereas the mercury does not sticks to the walls of the capillary tube. What is the anomalous expansion of the water? Tell me. If the temperature of the water increases from
4 degrees Celsius to 100 degrees Celsius.
Water increases from 0 to 0 degrees Celsius to
4 degrees.
What happened? Water contrasts.
contracts.
Water volume decreases. Water contracts. If temperature of the water rises from 4 degrees Celsius to 100 degrees Celsius, water expands. Is it clear? Water expands. If I decrease the temperature of the water from 100 degrees to 4 degrees Celsius, what happened? If temperature increases, temperature increases from 4 to 100 degrees Celsius. Here temperature increases from 0 to, if temperature decreases from 100 degrees Celsius to 4 degrees Celsius, what happened? Water contracts. If temperature decreases from 4 to 0 degrees Celsius, what happened?
Water expands.
Water expands. This different behavior in the region 0 to 4 is defined as anomalous expansion of the water. What is the use of this anomalous expansion? This is God creation. So in cold countries, the temperature of the surroundings decreases, falls to less than 0 degrees Celsius. Am I correct? In Arctica and Antarctica, the temperature of the atmosphere falls down below 0. Am I correct? If the temperature of the water falls down, what happened? It solidifies. Am I correct? It converts into ice. If entire water in the ponds and rivers solidifies, what happened to the aquatic animals such as fishes, tortoise,
They
crocodiles?
freeze and die.
Freeze and die. Am I correct? Because of this anomalous expansion of the water, aquatic animals like fishes, tortoise, and crocodiles will sustain their life in the cold countries. Why? Because if the temperature decreases, what happened? Water molecules contrast, volume decreases. What happened to the density? What happened to the density? Tell me. If volume decreases, what happened to the density?
Increases.
Density increases. Denser molecules will goes down. So lighter molecules will come up. As a result, the temperature, for example, temperature of the one cold country in the daytime, afternoon 12. Let us suppose that it is some 6 or 7 degrees Celsius. Clear? So temperature of the water which is present in the cold countries, rivers, ponds, lakes, temperature is also 6 degrees Celsius. So as a day continues, what happened if the day runs from 12 to some 4 o'clock like that, 4 p.m. like that, the temperatures slowly decreases. Am I correct?
Yes, sir.
The temperature decreases, what happened? Volume of the water decreases. Volume of the water decreases means what? It becomes denser. First upper layers temperature becomes decreases, becomes equals to the surroundings temperature. Let us suppose that surrounding temperature is reduces to 4. Then upper layers temperature also reduces to 4. These upper layers water becomes denser and they will push the lower molecules to the upper layers and they will settle down in the bottom layers. As a result, temperature of the waters which are present in the lakes also changes to some 6 degrees Celsius to 4 degrees Celsius like atmosphere. Once if the atmosphere temperature falls down from 4 to 0 degrees Celsius, the upper layers of the water, instead of contrasting, they will expand. As a result, what happened to the density of the upper layers of the water? Students, are you understanding what I am saying? If the temperature of the atmosphere falls down from 4 to 0 degrees Celsius, what happened? The water molecule will
Expand.
Expand.
water expands. What happened to the density? Density decreases.
Decreases.
Density decreases means the molecules, upper layer molecules becomes lighter. If the upper layer molecules becomes lighter, they won't pushes the bottom heavier molecules to the top layer. As a result, what happened? The upper layer of the ice only, the upper layer of the water only freezes into ice. The lower layers still, the lower layer still behaves uh, the lower layers of the water still temperature maintained at some lower layers behaves 4 degrees. Just below the lower layer of the ice temperature is 0 degrees Celsius. In between, the temperature of the water varies between 0 to 4 degrees Celsius. If the temperature is in between 0 to 4 degrees Celsius, this lower layer of the water still remains as a water. Is it clear? Student, are you able to understand?
Yes, sir.
As a result, aquatic animals won't freeze, won't becomes freeze, won't die. Is it clear?
Yes, sir.
They may ask in your examination. Let us suppose that they are going to provide you this anomalous expansion of the water. So most of the substance expands uniformly. If we increase the temperature, if most of the substance contrast uniformly if the temperature decreases, but our water temperature, if I increase from 0 to 4 degrees Celsius, instead of expansion, contraction takes place. If I increase the temperature of the water, if I increase the temperature of the water from 4 to 100 degrees Celsius, it will expand like all other substances. So this behavior of the water in between 0 to 4 and 4 to 100, this behavior of the water in between 0 to 4 degrees Celsius, like is called anomalous expansion of the water. How will you appreciate this? They will ask like that. You need to write descriptive orientation. So they will ask like that. How will you appreciate this anomalous expansion of the water in our surroundings, so in cold countries especially? How will you appreciate? Tell me. So you need to guess all these things. They are going to ask you some informative based questions, and they are going to provide you some information. Basing upon them, that some information there are they are going to ask you few questions. You need to answer. For example, here, so where the density of the water is more, at what temperature density of the water is more? How will you answer? Tell me. At what temperature volume of the water is less? At what temperature volume of the water is less? Tell me.
4 degrees Celsius.
4 degrees
4
Celsius.
degrees Celsius, volume of the water is less. Is it clear? Volume of the water is less. So, at 4 degrees Celsius, density of the water is more. So, they are going to provide you some information related to the anomalous expansion of the water. So, yesterday I showed you how they are going to ask you problems. Practical based questions, informative based questions, experimental based questions. They are going to provide you some information. Basing upon that information, they will ask you some problems. You need to guess. You need to guess as if it happens like that. So which things may happen? Which things may happen? You need to guess. If you guess properly, for 10 marks, you may get so around 8 or 9. If you guess very close to the actual answer, you may get partial marking, 4 or 5 like that. Is it clear? Yesterday I showed you one question paper. Am I correct? In that question paper also, they are asking experimental based questions, practical based questions, and informative based questions like that. These questions are very lengthy. So they will not ask you direct questions like in first level NSE exam, National Standard Examinations. Is it clear? They are going to ask you as a very lengthy questions and long questions. Even though if you answer 3 or 4, you can able to qualify for the next level. Especially these descriptive questions. So objective questions, what they are asking. So what is the uh, for how many marks they are asking? INO examinations, INJSO examination previous year, tell me. 180 marks. Am I correct? In first section, they provided some single correct answers. In second section, these single correct answers are your Olympiad based level questions. So IPL based, ICON based, so C batch based questions ఉన్నాయి కదా, అలాంటి questions అడుగుతారండి. Is it clear? But in multi correct also your IPL based questions only. But in the descriptive questions, they are asking practical based, experimental based, and informative based, skill based questions they are going to ask you. They are going to check your skills in this third section. So most of the student can able to answer the first section few questions, second section few questions. In third sections, will guess properly things. They'll get, these are the descriptive exams. These are the descriptive questions. You need to guess. If possible, please better to buy one book. As if I am going to show you that book. That book name is this HSBCS will conduct this examination. Am I correct? Students, please respond.
Yes, sir.
Yes, sir.
HSBCS conduct Homi Baba or science something. Am I correct or not?
Yes, sir.
So they will conduct until uh, last year, how many practical based questions they asked in the junior science examination? They are giving in one book format. So if possible, I am going to send through our Kiran sir. So who is conducting this Zoom meeting? I am going to send in your groups. Clear? Kiran sir. Kiran sir, please respond. Suryababu sir. So please, if possible, if it is available in our nearby book stalls, please buy those books and prepare nearly 39 experimental based questions I saw in that book.
Sir, what is the name of book?
So I'll send. I forgot that book name. So just 1 minute. I'll tell you. Uh, Collection of experimental problems. Book name is it clear? Nearly I saw nearly 39 or 40, more than 40 problems. Once check. These are previously asked in junior science. Is it clear?
Sir, I have a doubt.
Tell me.
Sir, that is section 3. This book we have to prepare for the
If you
section
prepare,
3
you are going to get some idea how they are asking, how they are handling the situations.
on a total question paper or only section 3?
In section 3, they are asking experimental based questions,
Okay, sir.
practical based questions. Previous year, so it is the best book what I saw now, up to now. This is also released by there is HSBCS. Clear? Homi Baba Center for Science and Technology, something abbreviation is there for that HSBCS. Is it clear? So they are going to provide this anomalous expansion of the water and they will ask you based on this. Is it good or bad? If it is good, how will you uh, support your answer? They are going to ask you like that. Is it clear? So yesterday I asked, so I gave మళ్ళీ మనం deviate అయిపోయామండి. So once the rod is coming to its steady state, what happened? The rate of flow of heat through the each cross section of the rod, what we call the heat current, directly proportional to temperature difference between the ends and inversely proportional to length, directly proportional to cross sectional area, and directly proportional to K. K is called here coefficient of thermal conductivity, which depends upon the nature of the material of the rod. Students, I think you are getting bored. Am I correct?
Yes, sir.
So can I stop? From tomorrow onwards, I think you are getting holidays. Am I correct?
Yes,
Any
sir.
Yes.
Hmm? So even though there is a holidays, so we are conducting these classes continuously. Please attend these classes at least from this allotted time 7 to 7:45 and 7:40 to 8:30 like that. Am I correct? Please attend these classes and learn something related to this INO. Suryababu garu. Suryababu sir.
Sir, tell me, sir.
సార్ కంటిన్యూ చేయమంటారు ఒక 10 minutes లేకపోతే క్లోజ్
Okay,
చేయమంటారు?
sir. Sure, sir. Sure, sir. Continue చేయండి.
ఓకే సార్, మీది ఇదే ఐడిలో కంటిన్యూ అవుద్దా కెమిస్ట్రీ? సూరిబాబు సార్,
Sir,
ఇదే ఐడిలో కంటిన్యూ అవుతుందా?
yes, sir. నెక్స్ట్ కెమిస్ట్రీ క్లాస్ ఉంది 8 o'clock కి.
8
సో 10
o'clock.
minutes ఉంది కదా సార్, మీరు కంటిన్యూ చేయండి.
ఓకే అండి, ఓకే.
ఓకే సార్.
Students, yesterday I gave one problem to you, so I am going to tell you that solution. What I asked in the previous class, before leaving the class, what I asked, tell me. There are two vessels, vessel A and vessel B, with different liquids. One is, let us suppose that it is water. Another one is, let us suppose it has some other liquid. This is water. Let us suppose that this may be a milk. Clear? The mass of the water is M1, whose specific heat capacity is S1. Mass of the milk is M2, whose specific heat capacity is L2. These two vessels are connected by a rod, whose cross-sectional area is A, whose thermal conductivity, coefficient of thermal conductivity is K, and length of the rod is L. After how much time? What is the initial temperature difference? Initially, temperature of the water is T1, temperature of the milk is T2. Initial temperature difference is how much? Here they mentioned that temperature of the water is more than temperature of the milk. Temperature of liquid A is more than temperature of the liquid B. After how much time temperature difference between the two liquids becomes half of the initial temperature difference they are asking. Initial temperature difference is how much? Initial temperature difference is T1 minus T2. Final temperature difference is given as T1 minus T2 by 2. After how much time final temperature difference between the two tanks becomes half of the initial temperature difference they are asking. This is hot body, am I correct? This is the cold body. So I also mentioned that as the temperature, as heat transfer takes place from rod to the, through the rod from liquid A to liquid B, neglect the heat losses to the surroundings by the rod and by the vessels. There is no loss of heat energy to the surroundings, so they are covered with insulating materials, I said. Is it clear? So here, as heat energy transferred from liquid A to liquid B, what happened to the temperature of the liquid A? Temperature of the liquid A decreases. Am I correct?
Yes, sir.
Temperature of the cold water, so cold milk increases. Am I correct or not?
Yes, sir.
Rate of heat lost by the water A becomes how much? As heat transferred, the temperature T1 decreases. Temperature T1 decreases and temperature T2 increases as heat transfers. Clear? So dq by dt, already you may learned in our previous classes, 7th or 8th, we completed calorimetry. If you supply heat energy to the water, let us suppose that heat supplied is utilized to increase its temperature. Few calories of heat energy we supplied. As a result, its temperature changes from T1 to T2. Its temperature increases from T1 to T2. Its mass is M. What is the expression for Q? Q equals to ms delta T, T2 minus T1. Clear? Here we are going to use Q equals to ms delta T. Delta T can be expressed as dt. dq can be expressed as ms delta T, where delta T is increase in temperature or decrease in temperature. Here first case, for liquid A, dq by dt becomes how much? ms delta T 1 divided by dt. This can be expressed like this. Here temperature of the first body decreases. That is why we can use a negative sign, m1s1 minus of dt1 by dt. Here minus sign indicates that the temperature of the liquid one decreases. Liquid A decreases. So same equation for liquid 2. How we can write? Tell me. For liquid 2, for liquid B,
M1
temperature increases.
M2S2 into DT2 by DT
M2 S2
into DT2 D1 T2 by DT.
dt. Is it clear? Rate of flow through the rod A. As yesterday I explained, rate of flow through the rod A. The rate of flow through the rod A is how much? Through the rod A is dq by dt. As yesterday I explained it as h. I explained it as h. Am I correct? H is equals to k a temperature difference T1 minus T1 minus T2 divided by length. What I used yesterday is what I explained yesterday in conduction process. Is it clear? This is the rate of flow through the rod, which is equals to how much? Tell me. Which is equals to minus for rod A minus m1s1 delta T1 by dt, which is equals to Ka into T1 minus T2 by L. Similarly, for rod 2, this equation becomes m2s2 dt1 by dt, which is equals to Ka into T1 minus T2 divided by L. If I make dt1 by dt minus dt2 by dt, what we are going to get? Tell me. Here Ka by L is constant. This can be expressed as dt1 by dt as Ka by L T1 minus T2 divided by M1S1. Am I correct? Similarly, dt2 by dt is equals to Ka by L, not here, not plus, minus. Here temperature increases. Ka by L T2 T1 minus T2 divided by M2S2. If I make dt1 by dt minus dt2 by dt, in which rate temperature decreases? In liquid A, in which rate temperature increases? Temperature increases. In liquid B, that difference, what we are going to get? Tell me. If I substitute here, if I take minus common, 1 by M1S1 plus or minus M2S2 T1 minus T2 we are going to get. This can be expressed like this. T1 minus T2 by dt which is equals to minus Ka by L 1 by M1 S1 plus 1 by M2 S2 T1 minus T2. If I rearrange this equation, we are going to get like this. Minus Ka by L 1 by M1 S1 plus 1 by M2 S2. If I integrate on both sides with limits, what are the limits? Tell me. Initial temperature difference is how much? Final temperature
T1 minus
difference
T2.
is
T1 minus T2 by 2.
minus Ka by L. Here dt also there. Anyhow, the first bracket terms are constants. M2 S2 integral dt. Integration limits are some 0 to t. If you integrate, we are going to get the final answer is like final answer of t is like this. M1 S1 M2 S2 into L by Ka into M1 S1 plus M2 S2 log 2 like this. We are going to get like this. You know that integral dx by x is how much? Tell me. This is in the format integral dx by x. Integral dx by x is how
Log
much?
ln x.
Ln x. Ln means log base e. Ln x means log base e. Is it clear? So after substituting the limits, what you are going to get? With this minus, we can reverse the limits. Am I correct? You are going to get like this. Ln T1 minus T2 by 2 divided by T1 minus T2. You are going to get ln 1 by 2. If I bring this minus this side, so we can write ln minus 1 by 2 as 1 by 2 minus 1, which is equals to ln 2. Are you understanding how I integrate this left side term?
Yes, sir.
So I'm closing
Yes, sir.
this class.
Sir, once you scroll up, sir. Stop.
Is it okay?
Yes, sir.
So I think you have some other class, chemistry class. Please attend that class. Tomorrow also we will have physics class according to the schedule, but next 2 days there is biology, zoology, it seems. Please attend
Excuse me,
next
sir.
classes also.
1 minute, sir.
Tell
1
me.
minute. Screen.
Excuse me,
Screen.
sir.
I will take screenshots.
Sir.